Welcome to this video. In this series we will be simplifying the different network diagrams in project management and scheduling. Please let us know if you found this helpful down in the comments below. And don't forget to click the subscribe button. We will be working with this activity schedule. And we will use it to construct the activity on node network diagram. We will simplify forward and backward passes. Determine the project completion time. Calculate the slack values. And lastly, we will state the critical path. We will be using the following node convention which you can find in Quantitative Methods for Business written by David Anderson. The A represents the activity being described. And T represents the expected project duration. ES is the earliest time that the activity can start. EF refers to the earliest finish time. LS is the latest start time. And LF is the latest finish time in which the project will be completed without extending the minimum completion time. Let us go ahead and draw the activity on node diagram. I recommend that you start with a sketch. This is to make things easier when you complete the network diagram. We will start with both activity A and activity B because they do not have any predecessor. Activity C needs A to be completed before it can start. Activity D relies on both A and B to be completed before it can start. Activity E needs D to be completed before it can start. Next, we can see that activity F has two predecessors, C and E. Therefore we need to ensure that we can see this in our diagram. Lastly, activity G needs E to be completed before it can start. Additionally, F and G have no successors, so they will go to finish. Now that we have completed the sketch, let us draw the base of our activity on node diagram. Do not panic just yet. The best way to simplify this diagram is to draw the base of each activity using the node convention we mentioned earlier in this tutorial. As seen in our activity schedule, the estimated duration or the expected time for activity A is 1. The estimated time for activity B is also 1. Next, the activity duration for C is 2. Follow this logic to complete the base for all your activities. We will start by completing the earliest start and earliest finish values using a forward pass. We will start with activity A. A has no predecessor, so the earliest start time will be 0. Since its expected duration is 1, the earliest finish time will be 1 plus 0. This will also give you 1 for the earliest finish time. Activity B also has no predecessor like activity A, therefore the earliest start time will be 0 and the earliest finish time will be 1 plus 0. That will give us a 1. Next, activity C needs A to be completed before it can start. Since the earliest finish time for activity A is 1, then the earliest start time for C will also be 1. To calculate the earliest finish time for C, we will add 2 plus 1. This will give us 3. The activity D needs both A and B to finish before it can start. In our case, both the earliest finish times for activity A and B are 1. So this means that the earliest start time for activity D will be 1. In a case where these numbers were not the same, since this is a forward pass, you would have taken the highest earliest finish time between preceding activities A and B. Next, we will calculate the earliest finish time for activity D. It will be 14 plus 1, which will give us 15. Activity E has only one predecessor, which is D. So the earliest start time for E will be 15. Then to calculate the earliest finish time, we will add 5 to 15. That will give us an earliest finish time of 20. Next, activity F has two predecessors, C and D. As mentioned earlier, because this is a forward pass, we will take the highest value from C and D. This means that the earliest start for activity F will be 20. The same concept will apply for calculating the earliest finish time. We will add 2 and 20. This means that the earliest finish time for activity F will be 22. Since G has only one predecessor, E, this means that it can start earliest at 20 and finish earliest at 22. Now that we have finished the forward passes, we can determine the project's earliest finish time. This will be the highest earliest finish time value in our activities. G and F have the highest earliest finish time, which is 22. So we will say that the project's completion time is 22 weeks. I hope you have been taking your notes as we are about to move into backward passes. If you are finding value in this video, then please like and leave a comment down below. Do not forget to subscribe. Now let us do the backward pass. Since the project's completion time is 22 weeks, the latest finish times for the activities at the finish nodes F and G will be 22. In a nutshell, this means that activities F and G cannot be completed in longer than 22 weeks. Next, to find the latest start times, we will subtract the activity times from the latest finish times. For G we will subtract 2 from 22. This means that the latest start time for activity G will be 20. For F, we will also subtract 2 from 22 to get the latest start time of 20 weeks. E has two successors which are activity F and activity G. The latest start time for both activities are 20. This means that the latest finish time for activity E will also be 20 weeks. Please note that because this is a backward pass, if the latest finish times for activities F and G were not the same, then you would have chosen the lowest time to become the latest finish time for the activity. This is very important and I will repeat it. In a backward pass, if you have two successors for an activity, you will take the lowest latest start time and use it as your latest finish time. To calculate the latest start time for activity E, we will subtract 5 from 20. That will leave us with 15. Now, activity D only has one successor which is E. The latest finish time for D will be the latest start time for E which is 15. To find the latest start time for activity D we will subtract 14 from 15. That will leave us with only 1. Activity C has only one successor which is F. Therefore, the latest finish time will be 20. And the latest start will be 18. Activity A has two successors which is C and D. As mentioned before, because this is a backward pass, we will take the lowest value from the two activities. This means that the latest finish time for activity A will be 1. And that the latest start time will be 0. Respectfully. Lastly, we will look at activity B. Activity B has only one successor which is D. This means that the latest finish time for activity B will be 1 week. And the latest start time will be 0 weeks. We have now completed our backward pass. So listen attentively because we will discuss slack. Slack can be defined as how long the activity can be delayed, without extending or increasing the project completion time. So how do we calculate slack? It can be calculated by LS minus ES, or LF minus EF. In essence, the slack for activity A and activity B will be 0. For activity C, we will minus 1 from 18 or minus 3 from 20. So this means that the slack for activity C is 17. Next, looking at the values for our next activities, we will then conclude that the slack for activities D, E, F, and G is also 0. Let us look at activity C again. The slack is 17 weeks. This means that activity C can begin any time between the 1st and the 18th week. And it can finish any time between week 3 and week 20. Thus this means that activity C can be delayed by up to 17 weeks and the project will still be completed in week 22. On the other hand, the slack for activities A, B, D, E, F and G is 0. This means that these activities cannot be delayed at all, not without extending the project completion time. For example, if activity A is delayed by 3 weeks, the project completion time should also be extended by 3 weeks. This means that the project will now end at week 25, instead of week 22. The activities where the slack is 0 are called the critical activities. Critical activities form the critical path. Therefore, the critical path for this activity schedule is A, B, D, E, F, and G. We really hope that you enjoyed this video. But most importantly, found it valuable. In the next part of this series we will also cover more network diagrams. Additionally, we will be showing you how to calculate the variance and probabilities. Check our description box for tutorial links to the videos. Last but not least, comment down below with any topics you would like us to simplify for you. Goodbye.